All right, welcome to The Explainer. Today, we're jumping right into a massive architectural battle that's happening in AI right now. This is a big one. It's a clash between two totally different ways of thinking. And honestly, the winner could change everything about how we use and interact with AI.
So it all kicks off with this really weird, kind of frustrating problem. You've probably seen it. You feed a super powerful AI a huge document, like a whole book or a giant piece of code, and it's amazing. It'll remember the first chapter and the last chapter perfectly, but what about that key plot twist buried in the middle? Gone. It just gets fuzzy. So what's going on here? How can these incredibly smart models have such a specific blind spot? Let's dig in.
Well, the folks who build these things have a name for it: context rot. And it's exactly what it sounds like. The more information you pile on, the more the AI's ability to remember specific details just rots away. And here's the crazy part, right? It means that giving an AI more information can actually make it dumber. The longer the input, the worse the output. To fix this huge problem, two competing camps have popped up, each with a totally different idea.
Okay, so in one corner, you've got the scale architect. Their motto is basically go big or go home. They believe you can solve any problem by just throwing massive infrastructure at it. We're talking more GPUs, more power, basically infinite memory. Just overwhelm the problem into submission. But in the other corner, you have the precision architect. They look at that and say, no, that's just clumsy. They argue that the answer isn't brute force, it's elegance. It's about using smarter algorithms, teaching the AI to focus its attention, to actually think better. So let's see how these two philosophies play out.
So, here's what we're going to cover today. We'll start with the infinite memory problem itself. Then we'll hear from Team Scale and the ring of power idea. After that, Team Precision gets their turn with the art of focus. Then comes the big showdown over that lost in the middle issue. And we'll wrap it all up with a verdict that hits close to home: the startup's wallet.
All right, let's hear from Team Scale first. Their whole solution is built on a simple, powerful idea. If your memory isn't big enough, well, just build a bigger one, an infinitely bigger one. And the magic behind this is a technique they call ring attention. The easiest way to think about it is like a high-tech circular assembly line. You take a whole bunch of GPUs, link them up in a ring, and then you can spread a massive computational job across all of them. Each GPU is like a worker on the line. It does its part, processes its piece of the puzzle, and then passes it along to the next one.
So here's how it actually works step by step. First, you take this massive input and you split it into chunks. Easy enough. Then each GPU in the ring gets its own chunk and starts working on it. Now here's the really brilliant part. As they finish, they pass the results to the next GPU in the ring. But get this, the time it takes to send that data is perfectly hidden behind the time it takes to do the next calculation. That communication delay, which is usually a huge bottleneck, it practically vanishes. It makes the whole thing insanely fast.
And what you end up with is a memory system that can just keep growing and growing. We're not just talking about adding a bit more RAM here. This creates a whole new level of capacity, letting the model handle an absolutely staggering amount of information at the same time.
Look, this isn't some science fiction idea. It's real. Google's Gemini 1.5 Pro is already doing this, processing a 1 million token context window. Do you know how much that is? That's not just a book, that's like a whole library of books, all held in the AI's memory at once. So yeah, problem solved.
Okay, but now let's hear the rebuttal from the precision architect. They'd say, 1 million tokens. That's cute, but all you've really done is build a bigger haystack. See, they argue the real problem isn't the size of the memory. It's the model's limited attention budget.
And this is a great way to think about it. Just like us, AI models have a limited working memory, a kind of attention budget. So even if you give it 1 million tokens to look at, its ability to find the one important detail, the needle in that giant haystack, gets stretched thinner and thinner. Every new piece of info you add actually makes it harder for the AI to focus. So no, brute force isn't the answer. Intelligence is.
And that's why we're seeing this major shift in the field. It's moving away from what we used to call prompt engineering, just finding the perfect way to ask a question. Now it's all about context engineering. This is a whole different ballgame. You're not just talking to the AI anymore. You're basically acting as a manager for its entire state of mind, carefully curating exactly what it needs to think about.
And they have a whole toolkit for this. You've got stuff like compaction, which is basically teaching the AI to summarize conversations to save space. There's structured note-taking, where the AI literally keeps its own memory file so it doesn't forget important stuff. You can even use whole teams of specialized sub-agent AIs that go deep on a problem and then just report back the summary. The whole point of all this is to get the AI to do deep, multi-step reasoning, a long chain of thought, not just react to whatever you throw at it.
So you see, the goal here is the exact opposite of the scale approach. Forget building a bigger haystack. The idea is to find the smallest possible set of the most important clues, the high signal tokens, that will get the model to the right answer. It's about giving it the needle directly so it finds it every single time.
Okay, so there you have it. Two really powerful but totally opposite solutions. On one side, infinite scale. On the other, surgical precision. So let's throw them in the ring and see what happens. How do they handle that core problem of the AI getting lost in the middle?
And just to be clear, this lost in the middle thing isn't just a feeling people have. It is a well-documented, scientifically proven problem. Researchers have tested this again and again. Models are great at remembering the stuff at the beginning and the end of a long document, but their performance absolutely tanks for anything you stick in the middle.
And if you plot it out, it looks exactly like this. You get this U-shaped curve, really high accuracy at the beginning, really high accuracy at the end, and then this huge, scary drop right in the center. And that's usually where the most important stuff is. So, back to our architects, how do they fix this?
Well, Team Scale's fix is to just make the haystack so unbelievably big and all-encompassing that the model is just forced to see everything. You just overwhelm the attention problem with sheer size. Team Precision says, no, don't give the model a haystack at all. Let's just engineer the situation so we can hand it the needle directly. Which, of course, brings us to the final and maybe most important question of all. Because for any real business out there, especially a startup trying to make its mark, the tech is only half the equation. The other half is what it costs. So when every single dollar counts, which one of these approaches actually makes sense for your wallet?
And this table really lays out the fundamental trade-off, doesn't it? If you go with ring attention, the scale approach, your hardware cost is through the roof. You need massive, expensive GPU clusters, and your ongoing cloud bill is going to be huge. Now, if you go with context engineering, the precision approach, your hardware and compute costs are way lower, but your engineering talent cost, that's what goes through the roof. You need a small team of absolute rockstar engineers who are masters of this stuff, and they do not come cheap.
And this is really the bottom line, isn't it? That idea of infinite memory, it sounds amazing. But the reality of that massive recurring cloud bill every single month, not so amazing. For most businesses, and especially for startups where every penny is being counted, that brute force approach of paying for a giant GPU farm is probably just not sustainable.
So in the end, it really boils down to this one question. What's your next big investment going to be? A server farm or a star engineer? Are you going to bet on owning the hardware, or are you going to bet on owning the talent? For a startup that needs to stay lean and move fast, the precision of a world-class engineer might just be worth a heck of a lot more than a warehouse full of GPUs. And that right there is the multi-million-dollar question at the very heart of this great AI memory debate.